Hey everyone, and welcome to The Explainer. I am absolutely thrilled to have you here with us today. We are doing something incredibly powerful in this session. We're going to completely decode Cambridge AS and A-level mathematics, specifically focusing on syllabus 9709. But listen, we aren't just going to sit here and stare at textbook formulas. That's not what this is about. Instead, we're actually going to get right inside the examiner's mind to master differentiation, focusing on those notorious product and quotient rules. So let's dive right into this. A senior examiner recently made a pretty bold claim. They said most students lose easy marks on differentiation, but after this, you won't be one of them. Think about that for a second. Differentiation is a place where so many marks are just needlessly left on the table. But today, we're going to change that completely.
Here's our roadmap for this explainer. We'll start off with the differentiation challenge, then we'll unlock the method mark strategy, outline some essential procedural frameworks, run through the deconstruct, solve, evaluate loop, and finally, we'll reveal the top examiner warnings. Let's get moving.
Section 1. The Differentiation Challenge.
When you sit down for a Cambridge 9709 exam, we all know the stakes are incredibly high. The pressure is on, and honestly, it can make even the very best mathematicians lose their focus. A massive trap that students fall into here is choosing superficial breadth over analytical depth. You might be sitting there thinking, well, if I just write down absolutely every differentiation rule I can remember, I'm going to get the marks. But examiners are not looking for a data dump. They really prioritize your ability to go deep and show structured, analytical reasoning over just superficially covering a ton of ground.
To put that into perspective, if you treat product and quotient rules as just isolated, standalone equations, examiners are going to note that your work lacks context, and you'll end up with average marks at best. But candidates who reference cross-topic connections, meaning they actually show how differentiation integrates with other areas of the syllabus, they achieve significantly higher marks. They're demonstrating a real understanding of the theoretical architecture, not just reciting a memorized formula.
Moving right along to Section 2, the method mark strategy.
I am honestly so excited to share this with you because this is the core secret weapon of top-tier mathematics students. The absolutely crucial point here is this. Math at the Cambridge AS and A level is not simply a binary game of right or wrong. It's just not. The method mark strategy means you are awarded marks explicitly for demonstrating the correct procedural process. So even if you, say, drop a negative sign at the very end and your final calculation is technically wrong, a beautifully structured method is still going to capture the vast majority of those points.
So I literally cannot emphasize this enough. Show you're working. It is the ultimate safety net that will save your grades. In complex product and quotient rule problems, there are usually 4 or 5 different stages of calculation. If you document your process clearly, the examiner can actually follow your logic and award you those precious method marks. An invisible mistake in your head, that gets 0 marks. But a visible mistake on paper, with the correct method clearly shown, that still scores.
All right, Section 3. Essential procedural frameworks. When you tackle any differentiation question, you really need a procedural framework that just triggers automatically in your brain. Step 1. Deconstruct the question. Step 2. Extract the relevant data, like identifying your U and V functions. Step 3. Select your analytical framework. Step 4. Execute with totally clear notation. And Step 5. Present your answer with the correct terminology. Following this exact 5-step sequence leaves absolutely 0 ambiguity for the person grading your paper. And tied directly to that framework are these strict presentation conventions. We are talking about using proper headings, correct mathematical terminology like dy over dx, applying appropriate formats, and using clear, precise annotation. Let me be super clear about this. These are not just optional stylistic choices. These are the academic benchmarks that structure your logical reasoning. If your paper is just a chaotic, scribbled mess of numbers, you are actively throwing away method marks.
Which brings us nicely to Section 4. Deconstruct, solve, and evaluate.
When you're deep into a complex, multi-stage analysis, cognitive overload is a very real threat. To prevent your brain from short-circuiting, use this specific loop. Identify the given information, break it down into logical steps, and then solve it systematically. After that, always check for reasonableness. Does your derivative actually make sense given the original function? And finally, make justified recommendations or conclusions if the question specifically asks for it.
A huge part of that loop involves graduating from just basic data reading to actual critical data interpretation. Look, anyone can just read a function off a page, right? That's kind of like just reading the ingredients of a recipe.
But critical interpretation, that's actually baking the cake. It means extracting data from texts or tables, interpreting the underlying mathematical relationships, and then drawing evidence-based conclusions about rates of change or gradients.
Now, you might think comparative analysis is something you only do in history essays, but believe it or not, it's totally required here too. If a question asks you to compare different functions or rates of change, you absolutely must identify both sides, clearly state the similarities and the differences, use clear comparative connectives, and, this is key, back every single claim with hard mathematical evidence from your derivatives. You really have to draw firm conclusions to secure those full marks.
All right, Section 5, Top Examiner Warnings.
Pay close attention, because this is perhaps the most urgent part of our explainer today. According to the data, there are exactly 3 major pitfalls. These are literal red flags pulled straight from Cambridge Principal Examiner reports that catch students out year after year. Let's make absolutely sure you aren't one of them.
Mistake number 1. Answers are just too vague. When you're applying the product or the quotient rule, you simply cannot skip steps or be hand-wavy about your algebra. The assessment framework demands real analytical depth. You need to drop the generalities and provide precise, specific mathematical details that prove to the examiner you know exactly how the rule operates.
Mistake number 2. Forgetting to check format and presentation. Remember those strict conventions we were just talking about? Well, this is exactly where they bite you. Sloppy handwriting, missing brackets in a quotient rule denominator, or failing to clearly indicate which part is U and which is V. All of that directly bleeds your method marks. Presentation is a core academic benchmark, so don't ignore it.
And finally, mistake number 3. Answers lack context. You can write out the most beautiful, elegant page of calculus, but if the question was about, say, the rate of cooling of a liquid, and you just leave a raw number at the bottom without any units or a contextual sentence, you lose marks. Isolated math without context completely fails the assessment benchmark. Your solution always has to be specific to the scenario you were given.
Wow, what a journey through the examiner's mind. Let's do a quick recap of the explainer. To truly master the 9709 differentiation papers, you must focus on analytical depth over superficial breadth. Remember that making cross-topic connections earns you higher marks. Always lean on the method mark strategy by showing all you're working. Follow the deconstruct, solve, evaluate loop to keep cognitive overload at bay. And whatever you do, avoid those top 3 warnings. No vague, unformatted, or contextless answers. The examiner is grading your structured reasoning just as much as your final math answer.
I want to leave you with this final, somewhat provocative thought. How will you structure your next product or quotient rule problem to guarantee every possible method mark? Think about it. The next time you sit down with a past paper, don't just calculate. Communicate your logic. Thank you so much for joining me on the explainer today. I really hope you're leaving this session feeling empowered to completely rethink how you tackle your next math paper. Keep learning, keep structuring your answers, and I'll see you next time.